Hi there, this is my second video introducing calculus. We ended up at the end of the last video saying that straight line graphs were a bit too simple. We want to calculate gradients and areas under graphs which are much more complicated, graphs which aren't straight lines. So this is what calculus is all about. It is cleverer maths that can work with graphs that are not straight lines. Now, calculus is divided into two main areas or topics. You can probably guess what those two areas are going to be. The first one is calculating gradients of curve graphs, and that's called differentiation. And the second area is calculating the areas under curve graphs, which is called integration. Right, we're going to start with the first of those two things. We're going to look at differentiation, calculating the gradient. Now you know how to calculate the gradient of a straight line. Let's just quick remember that. Calculating the gradient of a straight line is quite easy. You need 2 points, and then basically you find the difference in the y coordinates and divide it by the difference in the x coordinates. And that's it. Nice and simple. So how do we find the gradient of a curved line? Well, here's an example of a curved line, and you can see I've put a few blobs on it. It goes up and down. It's a wiggly line. What is its gradient? Well, its gradient is changing. Its gradient is different at every point. Now, how do you define its gradient? Well, its gradient of a curve at any point is the gradient of the tangent. So here's a few examples of some tangents at different points, and their gradient is different. So the gradient of a curve is not going to be a fixed number. The gradient of a curve is going to be different at every point. So how are we going to get an answer for the gradient of a curve? It's going to have to be an equation. So differentiation is all about starting off with a curve, an equation for a curve, and then changing it into a new equation, which is the equation of the gradient. The differentiation process helps us find the gradient equation. It's usually known as the derivative. This gradient equation can then be used to find the gradient at any value, at any point, any x value along that curve. Okay. Let's just go back to another example. Here's a velocity time graph and it's changing. Suppose we want to find the acceleration after 20 seconds. Now, the acceleration is going to be the slope of the graph. So we need to find the slope or the tangent of that curve at 20 seconds. So we go to 20 seconds, we draw a line up from 20 seconds where it hits the curve, and then we draw a tangent line at that point. And we want to find the acceleration at that moment in time, we would need to find the gradient of that tangent. So we'd pick 2 points, and then we would find the gradient between those 2 points. And in this case, it comes to 0.5526 or 0.55, and that would be the acceleration of that particular graph at 20 seconds. So let's make this clear. The gradient of a straight line is a fixed number. But the gradient of a curve is not a fixed number because the gradient's different at every point. So this means that the gradient of a curve will always be another equation, which we normally call the derivative. Now the derivative has a funny symbol or a name for it. We normally call it, looks like dy divided by dx, but we actually say dy by dx. We miss out the divided by and we just say dy by dx. That is called the gradient equation. Just to make sure you understand dy by dx, a funny symbol, why would we use that? Well, just remember how you work out an equation, the gradient of an equation, or a gradient of a straight line. You find the difference in the y coordinates and you divide them by the difference in the x coordinates. And that kind of might give you a clue to where dy by dx comes from. But remember, this is not the gradient across two different points. This is the gradient at one point only. This is the tangent to a curve. Yes, we could make up 2 points on that tangent, but really we're finding the gradient on a curve at a particular point, and it's the instantaneous gradient. Okay, a little bit more notation you need to know. When you have a graph of a curve, it's usually called y equals something with x in it. So y is a function of x, we say. So sometimes you write, it's written like that, y equals f brackets x. That means y changes as x changes. It's just a normal xy graph. But sometimes you will find that the graph is not y and x. It might be something else. It might be v and t. V might change with t, like velocity changing with time. And then you'd say v is a function of t, or v changes as t changes. If that's the case, then instead of using that symbol dy by dx, we'll now be using dv by dt. To be honest, it won't happen very often. Most of the time we'll be using dy by dx. But just you might meet other letters sometimes. So for example, what do you think the symbol would be if it was a graph of p changing with q? Well, I think that's fairly obvious. It's going to be dp by dq. Right, so now we know what we're going to do. We're basically going to start with an equation of a curve. It will be y of some combination with x in it. Y is a function of x. And then we're going to differentiate that equation to find the gradient equation. And that's also called the derivative. And we're going to start that equation with dy by dx equals. Once we've got the gradient equation, we will be able to put any value we like for x into that equation, and it will give us the gradient at any point on that graph. So in the next video, we're going to look at how we convert the equation of a curve into the gradient equation. Basically, I'll show you how you differentiate simple curves.